Hi everyone, hope you're doing well. I am back with another Unity tutorial. This time I'm doing something called a QuickTake, where I go through some simple concept and in a shorter form video that kind of gives you the information you need in a quick manner. So let's get started. So in this video, I'd like to cover the topic of the square magnitude member of the vector3 class. And why is there a square magnitude when there's also a magnitude? As you probably know, the magnitude of a vector is its length. And vector length is used everywhere in game development to figure out how far away 2 points are from each other, among other purposes. That we're not going to cover today, but the fact that square magnitude exists, there must be a reason for that. And many of you probably know or have heard that using the square magnitude is more efficient, faster than using just magnitude. So why is that? That's because to calculate the length of a vector, you take the x component, y component, and z component for a three-dimensional vector. You square each of them and add them together, and then you take the square root of all of that, and that gives you the length of that vector. When we compute distance between two vectors, we subtract one from the other, take the resulting vector, and get its magnitude. Many times in game development, we would like to, instead of just knowing how far away 2 points are, we would like to just compare to see if a point is further than a certain distance away. And for those purposes, we don't need the actual absolute distance. We just need a value that gives us enough for a comparison. And so because the square root operation has historically been something that computers generally take more CPU processing to compute, not having to do the square root means you might save a bit of CPU time. And since these types of comparisons are done potentially hundreds of thousands of times per frame, which is usually 1/60th of a second, this small amount of CPU time can add up. So what I did is I created a simple test framework here where I perform two different types of distance comparisons. One uses the square magnitude and one uses the magnitude. In both cases, the result is going to be the same, but we are measuring the time it takes to do each one. Now, I'll spare you the actual running of this test, but suffice to say, the results were conclusive that using square magnitude is indeed faster, at least on my CPU, which I'll show you here. And certainly, this being a pretty powerful Intel-based CPU, if it's faster using square magnitude on this type of CPU, on a ARM processor, on a phone, or other device, it's probably going to be even more of a difference. So here's a quick look at the script that I wrote for this test, basically just timing the operations. And I'll include a link to this in the description if you'd like to try the test yourself on your own hardware. At the end of the test, it will print out the results, and we're just going to take an average of the times that for the fast version of this comparison and the slow version of the comparison. And using this chart, you can see, regardless of the number of iterations, there is a distinct difference between the, quote, fast method using square magnitude and the slow method using just magnitude. And again, we are doing strictly comparing two vector lengths. One uses the square root method and one doesn't. So based on the data in this chart, and this is again using my hardware, your hardware might be different, you can see that on average we're saving about 7 nanoseconds per comparison. Now that might sound like a very tiny number, and it is, but in game development every millisecond matters. And as you can see, when doing this operation 50,000 times per frame, let's say, there's a non-trivial amount of time savings. 1/3 of a millisecond is actually quite a bit in a game. When you only have 16 or so milliseconds per frame, even fractions of a millisecond might matter. So what's the conclusion? In my opinion, it is more efficient to use square magnitude in place of magnitude for length or distance comparisons. If you need the actual distance for other specific reasons, then of course you can use it. And of course, unless you're doing that hundreds of thousands of times per frame, it's probably not going to make a huge difference. But given that there's virtually no reason not to use square magnitude and a potential reason to use it, my suggestion would be to use it everywhere you can when you need to. And one way to make that much easier is to use an extension method to the vector3 class, which I have shown here, which makes it much easier to know when to use the square magnitude or not to use it. And it's a simple function, and here's the usage of it. I can comment out this version and replace it with this version, and you can see that's how you would use it in your game. And from this point on, you never have to worry whether you're using square magnitude or not. This function can take care of that comparison for you, and you can be sure that it's using the most efficient comparison method possible. Okay, so that concludes this video. I hope you found it useful. Please like and subscribe, and please comment on anything I might have missed or anything else you'd like me to cover, and I'll see you in the next one.